In this demonstration of the Ext Chart program, we will compute the mod 2 cohomology of the second Eilenberg Mac Lane space for the group Z mod 2 using a modified or regraded Serre spectral sequence. The vibration used as input for the Serre spectral sequence is the path loops vibration, whose fiber is RP infinity, whose total space is contractible, and whose base space is the desired Eilenberg Mac Lane space. The mod 2 cohomology of RP infinity is known as a polynomial algebra on a single generator in degree 1. We will represent this generator by an element of degree -1, 0 in the spectral sequence. We'll compute only a range of information in the spectral sequence out to degree 10. And so I will tell the computer to keep track of the dots through dimension 10. This class is named iota1 for the first fundamental class. In order to speed up computation, I will explicitly inform the computer that we are only working up through dimension 10. There. Okay. Now, what used to be the base of the spectral sequence now lies along this diagonal, this up-left diagonal. And so the way that the spectral sequence computation proceeds is to introduce generators along this diagonal, which serve as targets for differentials off the bottom classes. So for instance, the first such class lives in degree 2 and is named the second fundamental class. We need 5 iterations of it before we exceed our 10 by 10 square. Then, this class is designed to serve as the target of a differential, which I will now add. Differentials in Ext Chart work by the following mechanism. They're assembled from various partial definitions, which give presentations of the differentials on designated subspaces of the source group. Here we have the T2 differential, and we will define it on a one-dimensional subspace. The left matrix describes the inclusion of the subspace we will include into the whole space. The right matrix describes the action of the differential on that subspace. I want to send iota1, corresponding to the 0th column, to iota2, and so I poke a 1 into the matrix at this location. When I click away, the change takes effect, and there's the differential. This differential, there are many other differentials in the spectral sequence, on this page even, but this is the important one because the rest can be inferred automatically by the computer. Using Leibniz rule propagation, I select the two generating classes and produce the following network of differentials. We then proceed inductively in the same manner. So the next class to be removed is iota2 squared. Iota2 squared has its target differential in degree 3. That class is named square 1 iota2. We need 3 iterations before we escape the 10 by 10 grid. Okay, so there's our old differential on the second page. On the third page, we would like to introduce a differential here. This is a D3 differential. It's once again defined on a 1 by 1, or a one-dimensional subspace of the source. It acts non-trivially. Then, using the Leibniz rule as expected, we have the following pattern of differentials. Something strange seems to have happened. This class does not belong. The reason that this has occurred is because when we first ran the Leibniz propagation on page 2, we only told the computer about 2 of the generating classes, but we have since added a third. To fix this problem, we simply rerun Leibniz propagation. There are 3 generators on this page now, as selected. And now we can see that the computer detects more differentials. When we turn the page, we see a better picture. This class has its target differential in degree -5. That class is named square 2 square 1 iota2. As we go, we will recompute the Leibniz rule. And here we are. I'll introduce a single differential. Now here, the target of this differential has the potential to lie in any chain, meaning that it does not account for the fact that by the time we have turned to the 5th page, there is only a one-dimensional group of cycles. And so we must sort through and select the chain that we want. And it's this one. This is the chain square 2, 1, iota 2. Once again, we ask for propagation. And we have one more differential to add. Here it is. D9, convention 1. Once again, I must sort through and find the class which I've forgotten to relabel. Here it is. Square 4, square 2, square 1, iota 2. And when I turn the page, I see in my selected grid exactly the expected value. I have a blank, I have an empty spectral sequence. One can flip back and forth through the pages as desired. And one can read off the generators up in this top diagonal from the right-hand panel. There's a generator iota 2, square 1 iota 2, square 2 square 1, square 4 square 2 square 1, and that's it.